something arrived from the direction of the galactic center. It was moving at 58 kilometers per second, almost twice Earth's orbital speed. It was going backwards, traveling in the opposite direction of every planet we have ever tracked through this solar system. Telescopes calculated its eccentricity at 6.1. No natural solar system object reaches 1.0. The simple explanation arrived immediately. An interstellar comet, the third in 8 years, active and confirmed. That should have ended the story. Then the James Webb Space Telescope measured its chemistry, and the fingerprint matched nothing in the database. The discovery came on July 1, 2025. The Atlas Survey Telescope, Asteroid Terrestrial Impact Last Alert System, funded by NASA, flagged the object from its station in Rio Hurtado, Chile. It was already inside Jupiter's orbit, at 4.2 astronomical units from the Sun, already falling toward perihelion under the Sun's gravity. When the trajectory was computed, the eccentricity returned at 6.1. No comet, no asteroid, no object born from this solar system approaches that number. The physical ceiling for a bound orbit is 1.0, and everything above it is a path that exits and never returns. An eccentricity of 6.1 is not a borderline case. It is 6 times beyond any orbit this system could produce. The Minor Planet Center confirmed the interstellar designation within hours. The object was designated 3I Atlas. The I stands for interstellar. The 3 is because it is the third such object ever detected by human instruments. That number, 3, mattered for how the story began. In 2017, 1E Oumuamua passed through the inner solar system at 26 kilometers per second. It had no visible coma, no detectable outgassing, and an acceleration away from the Sun that no proposed natural mechanism fully explained. The scientific community spent years circling the problem. Proposals included nitrogen ice, hydrogen ice, and radiation pressure acting on a body thinner than plastic wrap. None achieved consensus. Oumuamua left before anyone could settle the case. The universe had offered its first interstellar visitor, and the visitor had refused to be understood. The question stayed formally open. Then came 2E Borisov in 2019, and the atmosphere shifted. Borisov was a genuine interstellar comet, active, coma-bearing, chemically recognizable, and cooperative enough that existing models could describe it. Scientists could point instruments at it and get answers that fit established frameworks. Studying it felt like something new had become possible, the methodical analysis of an object that had come from somewhere else entirely. When 3I Atlas was confirmed, the initial instinct was nearly reflexive. Another Borisov, unusual in origin, familiar in character, an object that could be labeled, studied, and released back into the galaxy on schedule. For a moment, the early data agreed. Hubble observed 3I Atlas on July 21, 2025. The images showed a teardrop-shaped coma, dust streaming backward from a nucleus under solar radiation pressure, exactly the structure expected from active sublimation. The nucleus itself was small. Early estimates placed the diameter at under 5.6 kilometers, later refined to between 440 meters and 2.8 kilometers across. Smaller than a city, crossing the solar system at 58 kilometers per second. The spectral slope matched primitive comets and carbon-darkened D-type asteroids, ancient outer solar system bodies whose red surfaces had been shaped by billions of years of radiation. NASA's lead scientist for solar system small bodies summarized it directly. It looks like a comet. It does comet things. It very strongly resembles the comets we know. That was not reassurance. That was the honest reading of what the early instruments returned. But honest and complete are not the same thing. The first crack appeared in archival data. Researchers pulling pre-discovery images found 3I Atlas in test satellite observations from May 2025, weeks before the Chilean telescope detected it, when the object was at 6.2 astronomical units from the Sun. Outside Jupiter's orbit, deep in the cold outer solar system, where temperatures fall far below the threshold at which water ice sublimates, water-driven cometary activity cannot occur at 6.2 astronomical units. And yet 3I Atlas was already active. The coma was already forming. Something was driving it from a distance where our standard models say nothing should happen. The provisional answer was carbon dioxide. Carbon dioxide sublimates at much colder temperatures than water. It can vaporize in the outer solar system, far from the sun's warmth, in regions where water remains completely frozen. Some solar system comets with elevated carbon dioxide content show early onset activity beyond Jupiter. So the early coma was unusual, but not technically inexplicable. The object was simply very rich in carbon dioxide. Then the James Webb Space Telescope measured exactly how rich. Webb's NIRSPEC instrument observed 3I Atlas while it was still inbound, at a heliocentric distance of 3.32 astronomical units. The data returned a carbon dioxide to water ratio of 7.6. Across the full catalog of solar system comets, hundreds of objects measured across decades, the carbon dioxide to water ratio averages between 0.6 and 1.0. Even the most carbon dioxide enriched outliers in that distribution fall far below this value. 3I Atlas, at 7.6, sits 4.5 standard deviations above the trend for the entire known population. Webb has observed the chemical composition of solar system comets with the same instruments. None returned a ratio anywhere near this value. In most scientific fields, 3 sigma constitutes a formal detection. 4.5 sigma means the distribution no longer contains what is being measured. This was not an edge case. It was a different category. The simple answer gets you to the surface. The surface is not the story. Carbon dioxide in a comet is ordinary. Its presence is expected. But a carbon dioxide to water ratio this far outside everything measured in this solar system forces a choice between 2 readings. Either 3I Atlas formed in an environment with fundamentally different chemistry, a different star, a different disk, different conditions imposed by a different part of the galaxy. Or its original chemistry had been substantially altered by a process acting over a timescale we do not usually associate with anything we classify as a comet. These were not equivalent conclusions. One explained the anomaly as a consequence of alien origin. The other suggested the anomaly was a record that something had happened to this object across an enormous length of time, and that what James Webb Space Telescope measured was not the original fingerprint, but a changed one. Then there was the direction it came from. 3I Atlas arrived at an orbital inclination of 175 degrees. In a solar system where every planet orbits the same direction within a shared plane, 175 degrees is not a tilt. It is a reversal. The object was traveling almost exactly backwards, counter to every current in the system. Its trajectory traced back through the sky toward Sagittarius, toward the galactic center direction, suggesting origins not in the nearby stellar neighborhood, but in the Milky Way's thick disk, ancient stars that formed early in the galaxy's history, when the universe was younger, more metal-poor, and planetary formation operated under conditions measurably different from our own corner of the Milky Way. On October 3, 2025, 3I Atlas passed Mars at 0.19 astronomical units. Closer than most spacecraft we have deliberately sent to that planet. Then it continued inward, retrograde, against the entire flow of the solar system. Perihelion came on October 29, 2025. At one point, 36 astronomical units from the Sun, roughly Earth's orbital distance, the Atacama Large Millimeter Array was tracking the object in detail. ALMA detected a discrepancy. 3I Atlas was 4 arcseconds away in right ascension from where pure gravitational mechanics predicted it should be. Something was pushing it. A non-gravitational acceleration was acting on the nucleus, deviating the path that gravity alone would have produced. The echo of 2017 was immediate. Oumuamua's unexplained deviation had generated years of unresolved debate. Now, 3I Atlas was showing the same signature. The same question returned. What was pushing it? Modeling answered it. Researchers demonstrated that outgassing from less than 1% of the active surface area, localized jets of CO and CO2 escaping from specific regions, was sufficient to fully reproduce both the magnitude and direction of the observed acceleration. Thermophysical calculations confirmed it. Monte Carlo simulations agreed. No exotic mechanism required. The push was natural, and the case appeared to close. But the explanation created a deeper problem than the one it solved. If jets escaping from less than 1% of the surface were powerful enough to visibly deflect an object of this mass, then the outer layer of 3I Atlas was dissolving faster than the simple model allowed. Material was being driven into space that had been locked in place for an unknown and possibly enormous length of time. And beneath it, deeper than the jets were currently reaching, deeper than any telescope had yet measured, something was being approached that had been sealed since before this planet formed. The acceleration was explained. The explanation opened a question that could not be answered the same way. Because if that much material was escaping the outer shell, something beneath it was being uncovered for the first time. Something that had been sealed inside this object since before Earth existed. And the only way to know what it was required staying close to an object that was already leaving. The question of what was dissolving into space from the outer layer of 3I Atlas led to a second question. How long had that outer layer been there? The answer required looking not at chemistry, but at velocity. 58 kilometers per second is a fast number. In context, it becomes something else. Earth orbits the Sun at about 30 kilometers per second. Objects in the solar system move at speeds shaped by that scale. The inner planets fast, the outer planets slow, the whole system embedded in a relatively calm pocket of the Milky Way. When an interstellar object enters the solar system at 58 kilometers per second relative to the Sun, that excess speed carries information. It tells you roughly where the object came from in the galaxy and, by extension, roughly how old it is likely to be. In 2025, astronomers Astor Taylor and Darrell Seligman published a calculation. Objects moving through the galaxy accumulate velocity over time through repeated gravitational interactions with passing stars, a process called velocity dispersion. The faster an interstellar object is moving relative to the local standard of rest, the older it statistically is. Oumuamua was moving at 26 kilometers per second, Borisov at 32 kilometers per second. 3I Atlas at 58 kilometers per second was moving at nearly double the speed of the previous two visitors. The kinematic age calculation returned a range of 3 to 11 billion years. Earth is 4.5 billion years old. Put those two numbers next to each other. 3I Atlas, at the low end of its kinematic age estimate, is roughly as old as this planet. At the high end, it predates our solar system by more than 6 billion years. The universe itself is approximately 13.8 billion years old. Whatever star system produced 3I Atlas may have done so when the galaxy was half its current age, when the Milky Way's thick disk was forming, when stellar populations were metal poor, when the conditions for building planets were different in ways we are only beginning to characterize. The 12% probability that 3I Atlas originated around a star with very low metallicity is not a dramatic edge case. It is a real possibility that this object was born in an environment we have never directly sampled, and the home star almost certainly no longer exists. Researchers used the Gaia DR3 catalog, a precision astrometric survey of nearly 30 million stars with full velocity measurements, to trace the trajectory of 3I Atlas backward through time. The goal was to find which star it had come from, to recover the system, the disk, the formation environment. 25 stars passed within 1 parsec of 3I Atlas's historical path. None could be confirmed as the source. The trail goes cold before the beginning of any reliable stellar record. A star that is 10 billion years old, or 7 billion, or even 5 billion, may have already completed its life cycle, expanded into a red giant, collapsed, scattered its outer layers, and faded to a white dwarf, or cooled below detection. The object that crossed our solar system in 2025 almost certainly came from a place that no longer looks anything like it did when 3I Atlas left it. We are holding something from a star we will never find, in a civilization of stars we will never know existed. That is the point at which the chemical anomaly begins to make a different kind of sense. The model that explains the carbon dioxide to water ratio of 7.6, the early coma activity at 6.2 astronomical units, the red spectral slope, and the altered surface chemistry was published by Maggiolo and colleagues in October 2025. It centers on galactic cosmic rays, high-energy particles that permeate the interstellar medium, constantly bombarding any object traveling through open space. When galactic cosmic rays irradiate a body over long periods, they interact with the ices and organic compounds in its outer layers. They break molecular bonds. They drive chemical reactions. Critically, they convert carbon monoxide, CO, into carbon dioxide, CO2, while simultaneously building an organic-rich crust on the surface. The outer layer becomes chemically distinct from everything beneath it. The deeper interior, shielded by the material above it, remains unprocessed. It stays frozen in its original state. What this model says is that the extreme carbon dioxide enrichment JWST measured was not the fingerprint of another star system. It was the signature of what galactic cosmic rays do to an object over geological timescales. The outer 15 to 20 meters of 3I Atlas had been irradiated for at least 1 billion years. That shell is thinner than a 5-story building, but it was the only layer any instrument reached. Every ratio, every spectral feature that made 3I Atlas seem chemically alien was the product of cosmic ray processing. It was not the face, it was the mask. The pristine interior, the actual material from the original star system, unchanged since formation, was deeper, behind the irradiated zone, unreachable without landing, without drilling, without somehow staying alongside an object that had been accelerating away from us since before perihelion. That interior remained sealed through every observation Hubble made, every measurement Webb returned, every ALMA data point, every telescope that tracked 3I Atlas across the inner solar system. And then, in late 2025, something changed. The NASA SphereX spacecraft reobserved 3I Atlas between December 8 to 15, 2025, after the object had passed perihelion. By then, 3I Atlas had reached its closest approach to Earth, 1.7 astronomical units, roughly 167 million miles, on December 19. That is close to the distance between Earth and Venus at conjunction. Close enough, in astronomical terms, that on a different trajectory, high-resolution imaging of the surface might have been achievable. What SphereX returned instead was spectroscopic data, and that data showed that 3I Atlas had transformed. Before perihelion, the object had been dominated by CO2 activity, with water ice features visible in its spectrum. After perihelion, the picture was different. Water gas emission was 40 times brighter. Cyanide, CN, had appeared, a molecule not previously detected in 3I Atlas's coma. Organic carbon-hydrogen compounds had emerged across the 3.2 to 3.6 micron range. The dust morphology had changed. A faint anti-tail had developed. The composition had shifted, in the span of weeks, from an object that resembled a CO, too heavy outer solar system body, to something closer to a fully active comet in complete sublimation. What the research team proposed was that the heat of perihelion had begun eroding the irradiated shell. The sun had peeled back the cosmic ray crust that had accumulated over possibly billions of years of interstellar travel. In doing so, it had uncovered material sealed underneath, trapped molecules, organics, cyanide compounds, chemistry that had been locked into 3I Atlas since a time when the galaxy was younger and the star that formed this object was still burning. These molecules had never been exposed to starlight. The first star they encountered, after billions of years in the dark between stellar systems, was ours. Then, 3I Atlas continued leaving. Think about where you are sitting right now. The ground beneath the building you are in, the atmosphere above you, the material in this planet, all of it traces back roughly 4.5 billion years, assembled from the remnants of a star that died before the sun ignited. The object that passed 167 million miles from this planet in December 2025 was possibly older than the ground beneath your feet. It carried material from a formation environment that predates this solar system entirely. The sun briefly heated its outer shell, unlocked chemistry from another epoch, released it into the coma, where it dispersed into space. And then 3I Atlas continued outward, past Earth's orbit, toward Jupiter, retrograde, against the entire current of the solar system, leaving. It is past Jupiter now, moving at 58 kilometers per second, carrying its pristine interior, the material below the irradiated shell, the original chemistry from a dead star system, still unread, still sealed, still unchanged since before this planet formed. That is the part that does not close. Not because anything is concealed, not because anyone failed to explain what was visible. The science was published quickly and openly, across multiple institutions and multiple continents. The GCR processing model is supported by laboratory experiments. The kinematic age calculation is grounded in well-established stellar dynamics. The post-perihelion transformation was measured in detail by instruments designed for exactly this kind of spectroscopic analysis. The open questions are not gaps in reporting. They are gaps in what the physics allowed anyone to reach. And then there is the larger implication, which the science raises carefully and the numbers support partially: 3 interstellar objects in 8 years. Detection rate models suggest the local density of such objects is high enough that the solar system is crossed by them continuously. Before modern survey telescopes existed, they passed unseen. Some still do. Objects born in dead star systems, carrying irradiated surfaces and pristine interiors, moving through this neighborhood on schedules no observatory predicted, and on trajectories that point back to stars that have already ended. The solar system is not a closed environment. It is a permeable region of space through which the history of the entire galaxy slowly passes, and most of that history moves through without being measured. Something arrived from the direction of the galactic center. It was moving at 58 kilometers per second, going backwards through a solar system it had never encountered, carrying a billion-year irradiation crust and a sealed interior from a formation event in a star that no longer exists. It passed 167 million miles from this planet. It released chemistry that had never before touched starlight. Then, it left. It is still out there, still moving, the interior still sealed, unchanged since before Earth formed, carrying information about a star we will never find, in a language we have not yet learned to read.